Hi, this is Roger from Kanka Labs, and today we'll tear down these three 4.5 digit multimeters. Now this video is in preparation for a video about the development of 4.5 digit multimeters in the last 25 years, at least those available in the hobbyist's price range. And these are the three testimonials from the late 80s or early 90s, from the 2000 and what's newest available for the hobbyist. So let's start with this venerable Metex M4650B, which was my first 4.5 digit multimeter, and let's see what's inside. So what I'm especially interested about is, let's turn it off beforehand, what are the protection measures they took for protecting the inputs and protecting the multimeter. And can we find something interesting, like the high precision voltage dividers, or however they did it in the late 80s or early 90s. And you have to unscrew these four screws anytime you want to change the battery or change the fuses. And you can see, don't worry about the knacking noise here, that's normal. So we have a 9-volt battery inside, and as you can see, even self-tapping screws and threads. And the first thing we can see is here, this 2 amp glass fuse, 5 by 20 millimeters. That's what, I'll enlarge this a little bit for you. That's how they did it in the early days of hobbyists' multimeters. I've seen these fuses even explode, so basically that's not the right way how the input, especially here it's the milliamps input, how your multimeter should be protected. We will later see in the two other multimeters that they have a very different kind of fuses to protect their amps input. So let's go on with unscrewing this. So I even got the schematic for this multimeter, and we will consult it from time to time to see where I already wondered. There were some ICs inside which were marked as HD-something, and here we can see one of them, HD08. I don't know what that is. So let's see. I can't get this plastic. Is it shielding? I don't know. This further out. You already can see that the build quality is not the best here. They have is it a botch capacitor here? Lying flat on its side. And here we have some residue from, I don't know, is it flux or whatever? But at those days, you were lucky just to get a 4.5 digit multimeter for 200 Deutschmarks. It was at that time, which translates to about 200 euros in today's money. Okay, this is a separate PCB with the switch contacts, and here we can see the input jacks. Even it's gold The whole PCB is gold plated. Okay, that's necessary for the contacts of the input switch. And what is this? Could this be even the hybrid thick film voltage divider? Might be. So can we see any protection elements? Here we have two 1N4007 diodes protecting the amps input. Here we have the current shunt for the 20 amps range. It's nearly touching here these parts of the PCB which have some extra solder. What's on the back? That's where the fuse is. So, and this 1 ohm resistor probably already belongs to the current measurement ranges, probably for the 200 milliamps range. And I've seen something in the PCB which looked like either a spark gap or a capacitor. I will show you the schematic in a moment. And this is what I meant here, which looks like a capacitor, but I think in fact because it's labeled GT1, this could really be a spark gap, and we don't have any further protections. No MOF, no metal oxide varistor, nothing else. So that was how they did it in the late 80s, early 90s. And if we take a look back here, perhaps you can see that in the middle there's a little slot, and I think this is really a spark gap. You can see also the slot here, which goes around halfway down to the bottom. And we have this little plastic tubing around it. Probably that if a spark occurs, that it doesn't go to the input jacks, but can only go upward. So, and what else can we see? Few capacitors here, 100 nano, 250 volts. So anything with any substantial high voltage rating. What is that? This here, 100 volt, something 0.01, 10 nanofarads. And now let's take a measurement if this is really the, hopefully, hybrid ceramic thin or thick film voltage divider for the basic voltage ranges. Okay, now my X-Tech multimeter is specified as around better than 0.1% in the resistance ranges. So we start with 100.00, so bang on, 100 ohms exactly. Next is 1 kilo ohm, and we're out 0.06%. So I even can't tell, is this the tolerance of the voltage divider here or of my multimeter? Next is 10 kilo ohms. So this certainly is the precision input voltage divider, 0.05%. Again, I can't say, is this due to tolerances here from a multimeter or from the resistive divider. And now from 100 kilo ohms upwards, the accuracy of the X-Tech multimeter becomes a little worse. So here we are 0.09% out. This is certainly from the multimeter tolerances. And next should be 1 mega ohm. Yes, it is. And you can see the tolerance now gets worse and worse because in the mega ohm, high kilo ohms and mega ohm ranges, the accuracy is not so good. And this should be 10 mega ohms. Yep. Okay, so I won't open this, but if I would, let's see if we can break inside easily, or if this is plastic welded ultrasonically or however. So I couldn't open this thing with my little metal spudger set, so they must have had a reason just to protect this. Usually you find this thick film hybrid dividers open, and I think that's quite a good idea to protect them from dust or anything like that. On the other side we can't see the magic inside, so because they look really interesting under a microscope. And another thing, here we have some of these strangely marked ICs which I already saw on the schematic. CDR HD07. They have a lot of these strange ICs all over the schematic. Here CDC HD05. I can't see at the moment the functionality where this goes to. It goes directly into the next IC. So I don't know if anybody of you can find out or knows what this thing is. Anyway, what we can see is that hobbyist multimeters in those days, they had minimal input protections. I don't know if the CAT classes were invented around at that time, but anyway, you don't have any markings. You can see here the ratings like 1000 volt, DC max 750 volts, AC max, and here 200 milliamps max, and the unfused one, but you don't have anything like a CAT rating. And the input jacks also, they are not slotted, but they are quite stable, and this thing serves me well even now in my home lab, now after 25 years plus. Let's see if we find a date code somewhere. Anyway, what do we have here? 91. Oh, yeah, already have it. Apparently this was the PCB, at least. The layout is from 1991 as it looks. So let's see what else we can find. So to get further inside, we probably have to take on the knob from the mode and range switch, but before that, for safety, we'll take off the battery. And let's see if we can simply draw this. Yep, just comes off easily. And now, oh, we have a second layer for the range switch. So we have these contacts here on the daughter board, and we have this here. By the way, the feel of the indents here in the range switch is quite good. Now let's see if we can pull this out now, or if we have to unscrew still. Perhaps here this little trimmer or potentiometer for the zero adjust of the capacitance measurement. Yep, this also comes off easily. And can we get it out now? Yep, that was it. All right. So here we are. Oh, a lot of these strange ICs. What's this? Is this a botch resistor? Here are the little trimmers. I won't touch any of them because I checked this multimeter once after 30 years and it was still very well in calibration. So it really looks like that Metex made their own custom hybrid ICs at that time, or let them make them and just labeled them with their own markings. Anyway, here we have two other date codes. 3rd week of 1991, and this is from 1990. So except for a few passive components and this little botch resistor here, a few trimmers, these are the contacts for the capacitance measurement, or the inputs for measuring capacitors. So now take a look at this hybrid here. Here you can see even the kind of, what are it, SMD components here, soldered on a ceramic carrier board, or here, this one here. So look how thick the components are, and they all seem to be either conformally coated or at least protected from the elements with protective film or whatever. So they went to some effort at that time apparently to make their own custom hybrid ICs. I'm quite surprised. I thought these, when I saw the schematic beforehand, I thought these were just normal ICs, just relabeled, but these are not normal ICs. So for 200 Deutschmarks at that time, quite a lot of specialized ICs. And I know as a voltage reference, they have the venerable ICL 8069 from Interseal somewhere inside. That looks like a TO92 transistor, so it could be one of these two. Don't know exactly, I can't see at the moment which one is it. Here you have the jack for transistor measurement, which was en vogue at that time, and probably the ADC is below the LCD, so we have to take probably still a few screws off to get down to the ADC. So let's see what we find when we take off these little nuts. I hope there are no springs down below when we lift this up. Oh, another daughter board. Oh, the zebra strips are coming off for the LCD. Okay. This is the ADC, Metex M8880. From my information from a forum that said it would be the ICL, what is it, 7129, the classic 4.5 digit multimeter IC from Interseal. It might be that, again rebranded. Could that be a date code? 78? I'm not sure. Or is it 87? Strange. So either they developed their own ADC at that time, or is it, here we have the respective quartz crystal. In the schematic I can see only a 100 kilohertz quartz, but we saw another quartz here on the PCB. So I will, and the solder qualities, look at that. This looks nearly like at least partially hand soldered. So anything, it works, but does not look very professional. And perhaps the ICL 7129 is below that, and this is This is only the LCD driver plus the driver for the bar graph, because from the schematic, yeah, here you can see the ADC is the ICL7129, and it says the outputs are going to LCD and to CPU. So this is probably a little microcontroller, perhaps only for the bar graph or for driving the LCD. So we'll screw this back together again. And hopefully the zebra strips are making contact again at the right place. This one here also looks like a botch electrolytic here, soldered directly with bent pins onto this, again, custom IC, HD08, whatever that is. So I hope this has come together again the right way. And let's see. Here we have the 10-turn trim pot, certainly for adjusting the reference voltage of the ICL8069 of the reference diode. So, and behind that I can see that looks like the piezo beeper. Let's see where we can get the LCD off. This is the protective cover here. All right. And how is that? We have these little bolts here. Perhaps we have to unscrew these bolts, although I don't know why we have these nuts on top of them. Well, let me get the right tool for that. So back with the right tool. Let's see. Yep. These standoffs or bolts come off extra. And now still I see. I think we have to unscrew this one here again and take off the bolts also, or the standoffs from there. Let's see. Yep. So this took obviously a lot of handwork to assemble it, and let's see. Yeah, now we're in, and we have some other zebra strips. And here it is, the ICL7129 ACPL, not the original from Interseal, but the Maxim equivalent from 7th week of 1990. We have, as we thought, our little beeper, our 10-turn trim port for the basic adjustment of the reference voltage. So let's see if we can see if one of these things, if we can see if it's the reference diode. Yeah, I can't get inside. Just really to read the markings, but one of these two must be the reference diode. And here we have the integrating capacitors, hopefully it looks like relatively good quality. So, and a lot of these custom hybrid ICs, IC HD12 and however they are called. So I think this was it for a look inside how they made 4.5-digit multimeters for the hobbyists down in the early 90s or late 80s. And thanks for watching today. I'll see if I can get this back together again, and in one of the next episodes we'll tear down the X-Tech Multimaster 570A. So that was it for today. Thanks for watching. Until next time, bye from Roger, bye from Kanka Labs. works again like a treat.